High-strength automotive steel coils arrive at the factory, forming the structural foundation of the vehicle body. Lightweight aluminum sheets and cast components are delivered and digitally logged into the production system. Plastic resins, copper wiring, and insulation materials are received and tested to ensure purity and correct specifications. Every raw material batch is inspected for thickness, purity, and certification before it enters production. Steel coils are unrolled and fed into the cleaning line before any forming begins. Heated alkaline sprays remove oil, dust, and rust inhibitors from the metal surface. Ultrasonic cleaning uses microscopic vibrations to remove fine contaminants from precision engine parts. High-speed air systems dry the metal completely to prevent corrosion and ensure strong welding and paint adhesion. Laser scanners measure sheet thickness in real time to ensure it meets strict tolerance requirements. X-ray systems detect hidden internal cracks or material inconsistencies before stamping begins. AI vision systems identify scratches, dents, and warping, automatically removing defective sheets from the line. Final manual inspections confirm that only flawless materials move forward into production. Large steel coils are unrolled and slit into narrower strips using precision rotary blades. Aluminum billets are cut into controlled sizes to prepare for later forming and machining operations. Prepared metal blanks are aligned and transferred to the stamping line for body panel formation. A powerful hydraulic press shapes the flat steel blank into a complex body panel within seconds. The stamped panel emerges with precise curves that define the vehicle's aerodynamic structure. Multiple presses work in sequence to ensure consistent shape, strength, and dimensional accuracy. High-precision laser systems trim excess metal to achieve exact panel dimensions. Automated punching machines create accurate mounting holes for bolts, hinges, and structural assembly. Computer-controlled systems mix pigments, resins, and solvents in exact ratios to create the required paint formulation. Each batch is tested for viscosity and color accuracy to ensure consistent finish and long-term durability. Molten plastic is injected into precision molds under high pressure to form interior and exterior components. The molded component cools briefly before robotic systems transfer it for trimming and finishing. The painted vehicle body moves through a high-temperature oven to cure the base and clear coat layers. Controlled heat hardens the paint, improving durability, gloss retention, and scratch resistance. After curing, the vehicle body enters a controlled cooling zone to gradually reduce surface temperature. Regulated airflow stabilizes the paint layer, preventing cracks, warping, and thermal stress before further handling. The vehicle body undergoes electrocoating, where an electric current bonds anti-corrosion coating evenly across all metal surfaces. Robotic polishing refines the clear coat, enhancing surface smoothness, shine, and long-term protection. Advanced robotic arms perform precise welding operations with speed, consistency, and minimal human error. Automated guided vehicles move vehicle bodies efficiently between production zones using programmed navigation systems. Ultrasonic testing checks weld strength internally without damaging the structure.
Precision measuring systems verify that body dimensions remain within strict millimeter tolerances.
Paint thickness is measured to ensure uniform coating and long-term corrosion protection. In the body shop, robotic systems complete thousands of precision welds to create the rigid vehicle structure. The engine and transmission are installed with digitally calibrated torque tools to ensure precise mechanical fitment. Interior systems, electronics, and trim components are assembled to transform the shell into a complete vehicle. A 3D laser scan checks body alignment, panel gaps, and surface accuracy against digital design standards. The car undergoes a water leak test to ensure complete sealing against rain and environmental exposure. Final electronic diagnostics verify that all control systems operate without faults before approval. A permanent vehicle identification number is laser engraved onto the chassis for global traceability. The vehicle is tested on a dynamometer to simulate real road conditions and evaluate engine performance. A controlled road test checks braking, steering response, and suspension performance before final approval. Completed vehicles are stored in climate-controlled facilities to protect paint, electronics, and interior materials. The result is a high-performance vehicle built with precision, safety, and advanced industrial engineering.